my name's Casey Hilliard. I'm a data analyst, data manager up in the Institute for Big Data Analytics. I primarily serve Meopower on the one hand and Meridian on the other, and they're both sort of research groups, research institutes that have a heavy data component. Meridian is mostly concerned with marine acoustic data and other sort of marine big data. Meopower is largely concerned with the marine environment, so they're sort of different foci. But both of them share in having a large amount of AIS data at their disposal, and that's one of my core responsibilities is for each of them managing that data set. And so with that in mind, I'm just going to give a brief overview on sort of AIS as a general data set, sort of some specifics of it. I'm going to, this is next. There we go. Describe sort of its native use, how it's collected. I'm going to talk a little bit about, I'm going to talk quite a bit about secondary uses, so other things that AIS data have been used for outside of its sort of initial and original mandate. I'm going to talk a little bit about the limitations of using that data in those contexts. Give some examples of working with AIS and some examples of where you could go and find AIS. You know, if this is interesting enough to you that you think you want to use AIS towards one of these or a different end, where you might find some of that. So I'm going to start with describing how AIS data is used, how it's used and how it was conceived. So if you imagine, if you look at this picture here with a large number of vessels in a set of open water. Imagine you're a vessel operator and you have nothing at your disposal but a radio, and you're at the bottom of the picture and you're trying to get to the top of the picture. Imagine how many calls you'd have to go out and make, and how careful you'd have to be watching to make sure that any of those moving and stationary vessels, you don't end up colliding with them as you sort of transit across that water. So if you're going just by a radio alone, that's going to be pretty tricky. As one example, most of those vessels have a dark blue or a black substructure, and the top of them is white. So color is not going to be a particularly good identifier. More than 100, 200 meters away, 500 meters away without binoculars, you're not easily going to be able to identify any of those vessels by name. So essentially, you're just sailing blind into that and hoping for the best and trying to react quickly if something starts to go wrong. So that sort of limitation is why AIS, Automatic Identification System, was conceived and eventually deployed. It's mandated by the IMO, the International Maritime Organization, and it's a means for vessels to sort of co-identify one another, both the vessel's identity themselves, and then a bit of information about what the vessels are doing, so the nature of their operation, specifically in respect of how they're navigating, so where they're going, how quick they're going, if they're turning, where they're eventually hoping to end up, things like that. It applies the regulations for carrying it. It's globally required for all vessels that travel internationally that are 300 gross tons or greater. And I'll show an example of that in a second. And for vessels that travel only within their own national waters for 500 gross tons or greater, as well as for passenger vessels that are traveling internationally with 1,200 passengers. Some key sort of limitations to that is that fishing vessels, because of the semi-sensitive nature of where vessels go to fish, this notion of fishing grounds, it's not necessary globally that they report. They're actually exempted. Generally speaking, pleasure craft are too small to be required to report. But there's sort of another option for those vessels. They can carry it optionally a smaller, lower power device. So to give an example of the sort of scope and size of vessels that we're talking about, on the left here, we've got a fishing trawler, incidentally not required to report, but it's a good in terms of scoping the size. So that's a vessel that's 300 gross tons. If you look on the far left here, we heard to sort of point out that these are, the large tractor tires you see on a tractor, right? So you can imagine that's probably 20 tractor tires, as an impromptu unit of measure. The one on the right is 500 gross tons, so you can see there's a big excavator on it. You could fit, probably 15 excavators along it. So they're fairly sizable vessels. You can imagine why, for example, a small jet boat is not going to be required to carry it. It falls, far below the cutoff for it. This is an example of sort of how AIS looks, or how an AIS unit looks to an operator. So the device on the left here is called an ECDIS. It's an electronic chart plotting system. And the information about the other vessels comes up on this for a mariner to look at. It'll display the names of the vessels that are nearby carrying AIS, what direction they're going, how fast they're going, et cetera, et cetera. On the right, there is an example of what that display looks like. So it looks like kind of a big mess when you just look at it sort of to an untrained eye. But you can see here these little individual triangle flags. Each one of those corresponds to a vessel, and then there's a little collar with the name of the vessel or a unique identifying number on them. So that's sort of how the operators are taking this information in. If you're plotting a chart, you might look at the vessels that are pointed towards the path you're hoping to take. Those are the folks you want to be in contact with, maybe trying to avoid. So at a global level, those rules I mentioned earlier, that's who has to carry it generally. Of course, other countries are, it's at their own discretion what other vessels they might require carriage. So in Canada, there's an additional rule that passenger carrying vessels, so small passenger carrying vessels, will be required to carry AIS. In the US, any commercial operators under 65 feet, which if you can sort of conceptualize it, it's definitely quite a bit smaller than those other vessels that were in the other pictures. And in the EU, as an example, fishing vessels on over 15 meters are required to carry. So again, much smaller vessels. This is worth mentioning, and I mention it because this colors the population of the data set. So when you're using AIS for a particular purpose, it's important to figure out to what degree are the vessels or operations or activities that you're looking at captured in that data set. If you're looking at pleasure craft in an area where pleasure craft are not required to carry AIS, you're going to have clearly a sub 100% population. You're actually going to have a much lower population because no one's required to carry. So it's very important to sort of use that to sort of eliminate bias in any analysis you're doing with that data. So in terms of payload, AIS has 27 different individual messages that are sent on this sort of spectrum. Most of them, numerically, if you enumerate them 1 to 27, most of them are actually used for protocol maintenance. So there are things like, a competent authority saying, this vessel, I'd like you to report a bit more often, or we shouldn't communicate at the same time. They use time division multiplexing, and there's messages about negotiating what slots each different vessel should communicate on. So there's quite a bit of that, which is generally not put to post hoc use. But these sort of 5 message categories are the ones that almost everyone are using if they're talking about doing some analysis on AIS data. Message 1, 2, 3, they share a similar schema. Those are the primary sort of have to carry it vessels. That's them reporting their position and speed. Message 5 is those same set of vessels reporting some identifying information about them. So the vessel name, a special identifying number called their IMO number if they have one, the size of the vessel, and what type of vessel they are. Similarly, for the vessels that don't have to carry AIS, 18 is the position message for those guys, and the corresponding sort of what we call static message, so about the vessel particulars, that's message 24. There's one other positional message that's used, and the sort of significance will come up in a little bit later, but this message 27 is for a vessel transmitting its position when it's far offshore. So initially this data set was sort of designed to be just ship to ship or ship to shore within the confines of how far an RF radio can transmit. So you're looking at 70, 75 kilometers at the maximum. So once you get into the open ocean, obviously you're not going to be covered. However, again, I'll get to this in a bit. It's common now that satellites observe these messages and pick them up for later analysis. So message 27 is a special, less frequent message to be transmitted when you're sort of anywhere. If you're in the middle of the ocean, you don't expect otherwise anyone being able to sort of hear your messages, that's when this one comes into play, and it's expected to be transmitted then. So I'm going to talk a little bit about data collection, as I alluded to. Just for reference, these sort of message type structures, row structures, are actual AIS messages in their sort of encoded form. I won't get into the particulars. This is bona fide AIS data. So yeah, the system was originally meant for just ships to help, avoid running into one another, for lack of a better term, and also for ships to call into port so that the port has a good handle on what vessels are nearby or under its mandate, who's out there that's coming in. Of course, with that data available, especially to ports, some of the port stations log the data. I mean, I'm sure ships do as well, but it became increasingly common as it was rolled out to the ship stations. Rather, the shore stations would just log everything that they received. That type of receipt by a shore station is usually referred to as TAIS or terrestrial AIS. The range is between 37 and 74 kilometers. It can, in exceptionally poor conditions or where there's anything that bars RF transmission, of course, it's going to be shorter than that. So if you have a lot of interference at that particular bandwidth, it's also common that messages are received hundreds of kilometers out of the ocean. But in terms of reliable coverage, where you expect to capture a vessel's message, 70 odd kilometers is roughly the max that you'd want to put as a boundary there. In or about 2010, it was determined by a group out in Norway that the power of these signals was sufficient that a satellite could pick it up. So basically there was enough power remaining and not very many barriers to transmission through the atmosphere, so you could pick it up from a satellite. Because you're picking it up from a satellite, it creates an interesting kind of limitation that I'll show in a minute. But essentially, where normally the spec for AIS was defined that you'd be able to capture everything within 75 kilometers, from a satellite, it has a much wider observing window. So then there becomes a problem in that the spec only allocated enough bandwidth and enough inter-vessel communication to do slot selection over 75 kilometers worth of area. But of course, a satellite has a multiple thousand kilometer window over which it observes vessels. So you're going to have slot collisions. So that's sort of one of the limits of capturing data that way. And of course, once it was determined that it was feasible, companies, sort of commercial enterprise, went to do this, realizing there was a value in having this data over the wider ocean as opposed to just near the shore. And there's two sort of primary companies that operate in that area, and one sort of startup company that's doing capacity building right now. So Exact Earth and Orbcom are the key players for getting that data. Here's sort of an illustration of everything. So you can sort of see if you've got vessels communicating amongst one another, if they're out here, obviously they're sufficiently distant from shore that the message isn't getting back on its own, so you capture it from a satellite, and then you downlink it when you're above the receiver, and then you've got much wider coverage. So the key piece, I think, why most people are interested in this, sort of on an ongoing basis, the folks that are using this day to day, they're mandated to use it. So they have to. They don't have a choice. There's some value in it. It's been recognized for them. People are opting into it. So, pleasure craft do use these so that they can see vessels. But a lot of the growing use is secondary to the original intent. So I'm just going to sort of give a rundown of areas where this data has already been used to good effect. And towards the end, I'll talk a little bit more about sort of new things. None of these, by the way, are sort of, I don't know how to put it exactly. None of these are closed questions. It's not, we use it for this and there's an end-to-end completed system and it's done. All of these have, room for improvement, so to speak. So one of the key ones that was initially for which AIS data reuse is port and waterway management. So, you can imagine you're operating a port, you have this new, easily collected set of data that describes where all the vessels are that are using your port. Well, it's quite simple then to just keep all of that data and then reuse it later to analyze how your port's being used, to look at areas where you might be able to be more efficient or make better use of what you have, right? The next sort of step in this, which again was used, the first two were certainly enabled by terrestrial data alone, whereas satellite comes into sort of more of the later applications. So assessment of collision risk was a natural, post hoc use of this data, given that it had an interest in preventing collisions in the first place. This sort of ties into port and waterway utilization, and that you assess how many vessels are there, whether or not they're taking relatively safe or relatively risky activities, and you can look at this post op and say, okay, well, no events happen, no collisions happen, but this is the activity that led to no events or led to events happening. Looking at risk of oil spill, generally not looking at the results in the aftermath of an overspill, but maybe oil spill, but the exposure to an oil spill. So if usually the vessels that carry oil, as an example, are very well outfitted to prevent spills, even when there is an accident. But you look at over the long term, eventually an accident could be expected to happen. And so you look at the traffic from AIS to see where that is more or less likely to happen. Similarly, marine mammal strike. So this is something that's come up recently in the news, but it's actually been considered through AIS for an extended period of time. Just where are vessels compared to where there are marine mammals that could be struck? One of the sort of looking back 2 to 5 years, as the satellite data for AIS became more available, and as countries required their fishing vessels to use AIS more frequently, there was a bit more interest in using this to quantify both the amount of fishing generally, but also where there was IUU fishing, so illegal, unregulated, and unreported fishing. So that came about from a variety of things. One, being able to look at AIS data and develop and understanding the patterns of movement in the vessels to be able to label data as fishing or movement. So you could then use that data to build a bigger map of where are people actually trying to catch fish. And then comparing that to where people were supposed to be catching fish, or where how much was a realistic amount of effort to be put into catching fish on paper versus what was actually happening. It's also used sort of in a policing manner, I guess, to look at where vessels that are catching fish are landing their fish. So are they landing their fish at somewhere that it's being reported and essentially logged, or are they taking the fish and depositing onto another vessel and it's going somewhere else to sort of launder the fish, so to speak? So that's another use that AI put to. And I sort of put the asterisk there. This, in a lot of respects, depends on whether or not the vessels that are doing the fishing are required to carry AIS. There's a large number of issues with that, beyond, they're required to carry it, are they operating it appropriately? So it gets a bit more complicated. This is one example. Global Fishing Watch is probably one of the more well-known applications of AIS data. They also pull in addition to AIS data, some other types of data that indicate where fishing activity and where catches is put in. This is just a plot sort of their global assessment of where fishing is. Of particular note, the areas that are dark are generally areas where either there's land or where fishing is prohibited, or where there's no one reporting AIS in that specific exclusive economic zone. So it's a combination of all those things where you have gaps. Break it up with a nice colorful. So among other secondary uses, so generally this data can be used to figure out if vessels are where they're supposed to be. So looking at marine protected areas, there's a lot of marine protected areas come in a lot of different forms. There's sort of no-go areas, there's no-catch areas. There are a lot of different types of prohibitions, but generally, if you can accurately label all the data with the categorization that applies to it, then you could look and see, are vessels actually observing these? Are they not observing them? Similarly, you may or may not be familiar, but there's actually in the summers now, speed limit restrictions within the Gulf of St. Lawrence area because of right whales. And so they actually use AIS to check to see if these vessels are observing the speed limit or not observing the speed limit. That's another sort of usage for this as well too. It's used in large-scale modeling generally of ships and emissions and impacts of ships, whether that is air pollution or, as mentioned earlier, oil spills, which is sort of more an acute event. But these ones in aggregate, you can look at the air pollution impact or the insonification of the underwater environment and use the AIS data to measure the ship presence in an area and then sort of expand upon that with a model of whatever the contaminant or pollutant or deleterious process is on top of that. The last one is sort of a more, it's only one, but it could be many, many. So often now AIS is used as sort of the first step of modeling, and it's a resource for extracting ship behavior. And so there are all sorts of different machine learning and data mining and any number of other processes to extract information about that presence just as a whole. So, you know, this is the first step, which presumably comes to one of these other secondary uses, but there's a very, very large body of research looking at AIS now as an input to other things. So it deserves many more points, but it's, I think, a bit beyond the scope of this. So this is just showing one example. Maybe I missed one. So this is looking at ballast water exchange. So vessels, you know, in the hull, they carry water where they don't, you know, to sort of balance out cargo. As they take on and leave cargo, they take on and leave water. Similarly, they're supposed to basically leave that water in areas that won't be damaged or harmed by it, by transmitting organisms. So this is an instance where AIS data was used to identify that a vessel was reporting that it was dropping its ballast water in somewhere that was totally harmless, but then in looking at the AIS, the corresponding, temporally corresponding AIS points, the vessel was actually nowhere near the locations that it said it dropped off its ballast water. So it's actually used for sort of an enforcement role in that respect. Limitations. So all of that stuff is super cool. AIS, it's aside from AIS, it can be very difficult to figure out where ships are as a point. But then when you use AIS to find out where ships are, it's very easy to overlook the fact that it's not a perfect representation of all these ships for a variety of reasons. So as a first one, I noted a couple different times, not all vessels are required to carry AIS. So the big outliers among this are pleasure craft. Pleasure craft are huge outliers because they're generally not available. Their presence is not available through any data set of any sort. Whereas if you look at correspondingly like cargo ships, eventually they go to port. Pleasure craft, not so much, and they're not prevalent here either. Small tugs that fall underneath those reporting requirements, pilot vessels, fishing vessels. So all of those have different reasons for which they may or may not be in the data set. The data stream itself is designed for real-time navigation. So all of the fields that were put into it, all of the characteristics, they were all only designed for onboard use. It was only afterwards that people said, hey, this is a great, this is a rich data set we can use for all sorts of things. But in doing that, you have to take on the limitations that were imposed by why it was designed. So it's important to keep that in mind for sure. Of course, terrestrial AIS is only near shore, and it's only where you've rolled out a shore station. So there are, you know, sections of shore that are not well suited. You know, they're uninhabited areas. It's unlikely that someone's going to put in a receiver. So it's going to be very difficult to know the vessels that are there. Just because there's not a town on shore doesn't mean there aren't hundreds or thousands or tens of thousands of vessels crossing this, you know, near this area. So on the flip side, satellite AIS can cover essentially anywhere. It has a lower capture rate than terrestrial AIS for a lot of reasons, but largely because of that larger footprint, it's necessary to disambiguate all these signals, so you're not going to get 100%. It's a lossy process. It's also more costly. So it's definitely more expensive. You know, there is a significant amount of dollars put into launching those satellites, so they want to make some, you know, they want to recoup on that investment. There is potential for spoofing or data alteration or inappropriate disabling of AIS. Of those three, probably the third is the most likely of them to occur. The other ones have been proof of concept, but it's unlikely that they're happening in any large amount. And almost in every case, the use of AIS will require data cleaning or formatting of some sort. So here's an example of coverage. So this is the Mediterranean Sea. You can see roughly the region, you know, gives a relative measure of how large an area an individual receiver might be able to capture. So, for example, devices set up in the port of Halifax can capture, inside out to the Bedford Basin, and then, out to the open ocean. So this is roughly how far open ocean. The plot to the right is the relative footprint size of satellite capture. So where this entire picture is easily within the footprint of one satellite. So it's a different sort of scale. Of course, when I had mentioned about satellite having a lower reporting rate, there are sort of two issues. One is the disambiguation. So you've got too many signals and you need to pull them apart. The other one is that relative to the Earth, the satellites are moving. So they're not in one spot all the time. So only at current do the satellite providers have a near complete coverage. So they have a revisit time of roughly 5 to 10 minutes. So on a given spot, satellite will be there and then gone for 5 minutes and then come back again and capture some more data. So you're going to have gaps on that scale with the satellite data. That means if you're looking at micro motion of a vessel, it's going to be trickier with satellite data than with terrestrial data. But if you, for example, are looking at fishing vessels, they operate offshore, and the terrestrial receivers are not going to capture their movements. So it's, it can be tricky. So this is just a little bit of sort of general, beyond the limitations, just things to consider in working with AIS. So as I mentioned, there's always going to be a bit of data cleaning and pre-preparation. Some of that is filtering out bad data. So that's, there are well-published, the spec is well-published, and when you have values like coordinates or speeds or things, it's easy to identify if they're out of spec. It just needs to be done. The reason why you wouldn't, for example, do that at source is that records can have, they can be fully incomplete or fully erroneous, or they might have one field which is erroneous. So that same record might be valuable in one iteration, but then totally wrong in another. So yeah, it's really at a per study that you want to look at that type of thing. If you recall back at the very, very beginning, the message types that indicate the parameters of the vessel are separate from the messages that indicate where they are. So almost always there's an interest in a particular suite of vessels, cargo vessels, or the pleasure craft that are in there. It's necessary to actually fuse the data set to itself just to get that basic level of stratification. So it's worth mentioning because, again, it's an imperfect process, partly because, again, some of the messages of each of those types are not always valid, and you have to sort of combine your cleaning with your preparation. The representation, so generally the AIS data itself are not particularly interesting for follow-on analysis. The raw data are not really what a lot of folks are working with. Usually it's a representation built from those that people go on to do some more work with. So whether that's building a sequence of points into a trajectory, selecting all of the reported names for a vessel into a corpus of text, it's usually, in addition to the cleaning, there's a representation development step. Another way to consider that is, so it's clearly movement data. So any way that you would build a representation for movement data, it applies here. But other folks are doing other ways to interpret this data. So for example, plotting, generating an image or a bitmap of the positions that a vessel has been. That's another thing that can feed into a CNN, for example. So it's subtle, it always needs to be sort of reinterpreted before you're going to send it off. This is an example of just I guess it's to show the relative prevalence. This took an infinitesimally small amount of time for me to find examples of, vessels where throughout time the reported name was inconsistent. In this case, it's obvious that these ones are just corrupted messages. You can see there's some extra characters added. This was Atlantic Bear, and then there's some other sigils in there. Same with Sigma T, and for this pilot vessel. These ones I use the name because it's easy to identify. This similar type of corruption will happen in all of the different fields. It's just the nature of the way that the message is sent by RF and then interpreted. You get some bad data here and there. You also get, so on the left is when you have gaps in data. So this is occasionally common with, for example, the satellite data. You can see here you've got clear gaps. There was no data over that period, so you can choose method N to fill in that gap. And you can do some interpolation. You can just ignore it, but it needs some kind of treatment or at least consideration. On the right, it's a big zigzag. It's all one vessel. So obviously some of those points are erroneous. So if you're going to use those linear segments that are generated, you're going to have to be careful about how you treat them and how you identify the ones that are wrong, because there are going to be some that are wrong. So what I showed there was just some trajectories that I generated. Most of the work that I do personally in helping the folks use the data that I manage is primarily GIS work. So I'm building trajectory representations and looking at the volume of traffic in a certain area, looking at the number of tracks that are violating a certain area that they're not supposed to be, that type of thing. You can then take that type of data that's just linear segments, and you can build that up into heat maps. So that you can look at, compare areas among one another. You can also turn those heat maps, if you look at slices in time as heat maps, then you can animate them, animate maps of where vessels tend to be going. For machine learning, it's a bit more tricky than that. So you'd be looking at smaller representations that can, build a bigger corpus of information to describe something. I'll just leave it there. Because of the way that these data are generated, you will always have, you'll have a ton of data in the beginning, but you're looking to have some kind of, qualitative judgment. There's vessels where they're not supposed to be. There's more here than there. You're going to sort of always be funneling this data down. So I'll give some examples, I guess, here. So the plot on the left is raw AIS data plotted by vessel over a short time span, so 2 years, I think. You can then take all those points and generate trajectories out of them. And you might be able to say something different with that than you can say the one on the left. In your interpretation, you might look at where the relative densities are. So the vessels could take any one of a number of paths through that archipelago, but it looks like they're taking this one. Or as another example of how you might interpret those, you might look at where those trajectories end and cluster those. Say, oh, these portions of the ports, even though the trajectories cover the whole port, this is where they tend to go more often. Then you can run that type of thing from a machine learning standpoint, run that over a longer time period, and you can look at behaviors that come underneath that. It's data sources. So this is often with AIS, the biggest question I have is, where do I get some? I would like some of this data. You've sold me on it. I would like to find some. The answer is always, it depends. You can collect it yourself. It's very, very easy to do. I have set up 2, maybe 3 receivers locally myself. When you collect the data, it comes in, you're not talking big data, so to speak, but you're getting enough that you could template online processes, because it's definitely coming in multiple messages per second. And the real key benefit of that is that there exist a number of sort of exchange networks. So if you're operating a receiver somewhere, you can provide that stream data to one of these groups, and they will in turn point the fire hose of all of the streams that they're receiving at you. And then that is a big data source. And you can use that to do all sorts of very interesting things. You can also, of course, purchase it. It's not cheap. I mean, it can be cheap, but it's not, generally speaking, cheap. There are more, the concept of educational licensing is coming to AIS. So it has not been cheap for the quotations I've done. That may not be the case in the future for places like that. You can also, of course, partner. So this is sort of it's not always available. So I work for two organizations, Meridian and Mealpower. Both of them have totally different scopes. But if you have a project or interest that's in scope for either of them, there are ways that you can avail of the data sets that they've licensed. So the three main ways that I see being able to get it. Just in summary, it is very valuable. It is the most valuable input in terms of quantifying where vessels are. If you want to know where ships are that are of moderate to large size, AIS is the way to figure out where that is. There's not really, I mean, there have been worse ways to do it in the past, but this is definitely, I can assure you, the best way right now. There are different ways to get it, I just talked about. And you can do tons of stuff with it. Like this is, the world is wide open with this stuff. There's far, far more not done with it, or stuff that's, the first baby steps have been done and there's tons remaining, than there is like completed stuff and, oh, this works perfectly and nobody needs to look at it again. So I guess that's the main bit there. I think I've run a little bit over on time. Okay, so if anybody's interested in these bits. So ongoing stuff, just to sort of tease about stuff that's not done at all. Right now I'm working on three sort of biggish or interesting projects. So one of them, we're looking at using AIS, labeling it with port areas, and also labeling it with ecologically distinct regions, and then building a network representation on that. And then we're going to submit that to a pile of different network analysis techniques. So that's one thing for looking at, the coincidence of vessels and problems with ecologically sensitive regions, for looking at commodities carried and patterns among ports visited. So that's one thing we're looking at. We're using AIS to identify repeat travel vessels in areas that are underserved by vessels of opportunity. Vessels of opportunity are vessels that voluntarily sample the ocean to determine the temperature and salinity and other oceanic conditions. So basically, we're trawling the AIS data to find out where there are vessels in underserved areas and saying, hey, would you guys like to participate in this? We're also building an application to model spatially the time to arrive from any sort of public vessel in times of need for search and rescue. So generally looking at areas in the ocean and saying, if you had an incident in this area of the ocean, generally, how long will it take for a vessel to arrive that isn't operated by, for example, the Coast Guard? And this will let the Coast Guard know where are areas that are underserved, not just by their resources, but by people in general. So that's the gist of things.
All right, so thanks, Peter.
Any questions?
I have a good one, I think.
Sure.
Yeah. You said it's self-collected.
Yep.
How complex is the receiver?
So you can buy off-the-shelf receivers that you fire them up with Wi-Fi, and they provide a socket, and you can just slurp the AIS messages off them. Or so that's sort of like the all-in-one, very simple. You find somewhere to stick the antenna, and off you go. You can also get USB software-defined radio dongles, and you can code them up yourself. So I've done one of each. Yep. 13? Yep. Mm-hmm. So it's usually more sort of holistic. So at the moment, it's tricky for, it's a very good question. It's tricky for a lot of reasons. The key reason is that the presence of marine mammals is not well known. And that's essentially universal across every type of marine mammal. The level of knowledge is very poor. To give an example, the one that I'm familiar with and that I've worked with some folks on is the North Atlantic right whale. It's a whale, it's very large. It's very sort of blubbery, and it's impossible to affix a tag to it. So it's impossible to tag the vessel, the whale to identify where they're going. So this is sort of one of the root problems as to why there are currently strikes ongoing, because it wasn't clear where the population of whales was. They had identified where they were. They weren't clear on where they were going or even why they're going there. So now they have some theses about why they're actually going, for example, into the Gulf of St. Lawrence. But they don't even then have 100% tracking of the vessels or the whales being there. So for this type of risk, it's mostly looking at general population areas and looking at whether the vessels in those areas are traveling at such a speed and are of such a size that they could cause mortality if they were going to hit those whales. There is some work ongoing now at using detections of the whales' chirps and essentially their speech to use that to detect when the whales are present. And that type of information can then be used to signal vessels in the area and say, hey, there are some whales here. Could you please take an appropriate speed that, if you were to strike them, it's not going to cause a mortality. Yeah.
Like apart from transmission, what are the factors that lead to bad data? Like basically, all the vessels would be transmitting data in a particular format on them.
Yeah.
So apart from transmission error or signal deterioration, like what are the factors to lead to bad data?
Those are the biggest ones, but it's prevalent. You can also have hardware failures as well. So anything exposed to a marine environment will eventually degrade. So antennas are sort of highly mounted on moving structures, so you can easily get damage to them. But yeah, so the just general RF signal loss is one of the big ones. For the satellite derived data, demultiplexing those signals is I don't know how to put this generously and critique it fairly, but there are certainly errors in that process. I have modest confidence. I also feel that it's a process that's evolving. So as they put more effort into that process, I think that part will get better. But I think there's still going to always be some element of it where there's unfixable errors, so to speak. A lot of a lot of that is sort of in the private environment. So it's not a published process that they're using to do this. So it's hard to say how much more gain they can get. But I noticed that it has been getting better through time.
All right. Now we're ready for the questions. Thanks, speaker again.
Cool. We got an exit code of 0, so it must